In April 2026, the Designing the Future 3 expedition spent 2 weeks exploring the South Atlantic aboard the Schmidt Ocean Institute's research vessel Falkor 2. IFLScience spoke with marine biologist Kakani Katija about the voyage and what makes these expeditions unlike anything else in ocean science.
There was something about being on that expedition and being surrounded by experts in engineering, experts in vehicle operations, experts in biology and taxonomy. And the fact that I could just lean over and ask a question of Dougal Lindsay, who is a world-renowned jellyfish biologist and has, described numerous species. And, I can ask him, is that something that's been described? And he could tell me accurately, yes or no. That was really special. That isn't normally something you have, like a resource that you have. And so to have all of these people working together with that expertise and, that appreciation with the similar goal, right? The mission that we all shared was just really, was really powerful for me. One of us would just say, oh, this is a jelly. And you would see that scientist run through and bust through the doors like Kramer and Seinfeld, like just excited about what they're about to see, right? Midwater expeditions aren't very common. A lot of researchers, particularly people who do deep sea research, they tend to just want to go right to the bottom, which is fine. Like there's obviously a lot of different animals there. There's a lot of processes to study. But what happens is then you miss everything that's happening in between. And so a midwater expeditions is really different because instead of optimizing your setup or your instrumentation to work on the bottom with a vehicle on the bottom, in this case, you're, optimizing things so that you are measuring things in the water column, and it changes the vehicle operations. Midwater communities tend to be filled with animals that are now either transparent or made of gelatinous tissues. And that actually traditionally makes it really hard to study those kinds of animals because, the traditional approach would be to use nets, like big fishing nets, to capture those animals, to then bring them up to the surface and then do observations in that way. And so that's one of the reasons why animals like siphonophores, there's so little known about them. These are colonial animals, they're gelatinous animals, and arguably the longest organism, if you can consider the colony a single organism, on our planet. What's fascinating about that is that means we can come across many siphonophores in the ocean that are unknown or undescribed, or at the very least, we've never seen the whole colony all in one piece. And if you think about historically the ways researchers or people who worked at museums would do this, like an example would be Charles Darwin. They would launch an expedition and then they would, go to a place like Galapagos, other locations, and then catch and capture and often kill, not often, like always kill, the animals that they are trying to describe and study. And so, it's the 21st century, and we can come up with other approaches and other ways to perhaps do similar things, or at least get similar information that can be used to describe these animals, but doing it in a really non-invasive way. Like, can we get all the information we need to, understand what this animal is, or at least distinguish it from other animals, and then just leave it alone? And so the imaging technology that we've developed essentially does that. We get non-invasively data about what the animal looks like. We can also, with these laser scans, because we have an imaging system that will do that, we can generate three-dimensional models of the entire animal. And that's really powerful because, the example of these siphonophores or other gelatinous animals, if you bring them up to the surface and pickle them, let's say, which is what is normally done for museum collections, what that animal looks like in a collection looks nothing like what the animal looks like in its natural environment. And so the idea is, if we combine imaging and our 3D scans and other imagery and maybe take a little bit of DNA from the animal, then we might have enough information to do a full species description. And so that is, part of the goal and the reason why we're out on this expedition. It was to demonstrate this process. Is this realistic? Is this feasible? And, so far, so good. We're really impressed with the results. That's the power of these 3D models, is once you have them, you can do all sorts of things with them. You can put them in virtual reality spaces. You can animate them. They can be assets used in a movie. Like, I think one of my snarky comments about one of James Cameron's Avatar movies was like, why have a fake looking jellyfish? Just use my giant larvation model. We're able to share this experience with anyone, right? The idea that through these dive streams, the things we were seeing for the first time, like the experts were seeing for the first time, anyone watching the dive stream was experiencing that as well. Thanks to these approaches and, improvements in the technology, there's so much more that we can be doing in this space that is more, inclusive and invites almost anyone to come along with us. And so I think that's a really exciting, time to be in when we're talking about ocean life discovery.